All right, welcome to the introduction to the sine curve. So if you were going to type in this graph into a calculator, y equals sine x, this is what it would look like. So I've done it on my calculator so you can see. It's a curvy little graph and it just repeats over and over. So what I've drawn here is one period. That's what we call one cycle. Okay, so the period of this goes through 360 degrees. So all of these little numbers that you can see here, these are degrees. It will become apparent later what all this stuff means, just go with it for now. So it means it has a period of 360 degrees. That means it repeats itself every 360 degrees. So if I started again here, this is like this bit here, and it's just going to go up again and then down again and keep repeating forever. So what we're saying is there's a couple of features we can look at. The topmost point is up here. So it has a max value of 1, and that's at 30 degrees, right? Sorry, no, it's not. It's at 90 degrees. Why did I say that? It has a maximum value of 1 at 90 degrees. It has a minimum value of -1, and that's over here at 270 degrees. Okay, so it has maximum and minimum values, and it has a period of 360 degrees. So we can find equivalent angles. So what we're going to do is we're going to look at this graph and find where some of these things are equivalent. So let's look at 30, for example. Okay, so 30 is here and here. So sine 30 degrees equals 0.5. Okay, this is 0.5 because this is 1 up here and -1 down here. And like I said, these were degrees. So when sine is 30 degrees, its value is 0.5. So what we can do is if we're asked when else does sine equal 0.5, we can just have a look at this line here and figure out when else it hits the graph. Well, it also hits down here. So sine 150 degrees also equals 0.5. So you can see that there are some repeating values. So if you wanted to know when sine equals -0.5, you would just go down to -0.5, look across, and look here. This is going to be, well, if this is 180 and we're going up by 30 every time, this is going to be 210 degrees. If I want to know when else that happens, I just go over here. And again, I'm going up by 30s, and this is 360, so that must be 330 degrees. So we have these equivalent values all over the place. So there's also a rule that we can use instead of just looking at our graph, which we've done. So if we use a general rule, we can say sine of x equals sine of 180 degrees minus x. And I'll show you what that means like this. So we'll use the examples we've already done. So sine of x, sine of 30, is the same thing as sine of 180 minus whatever we just said. So 180 minus 30 is 150, and these were our equivalent values. So to begin with this, we're really only going to be looking at values between 0 and 180. So you don't have to worry about the negative ones yet. The book is only going to deal with positive values. But this is the rule we want to use. I've just done an example, but I messed up my wording. So let's try that thing again. So what I was just trying to say is we're going to use this rule. Let's say we wanted to know what an equivalent value of sine 40 is. Well, we just use this rule. So the equivalent must be 180 minus whatever this was. So that's 40. So then the equivalent value of sine 40 is going to be sine 140. So these two have equivalent values. So if we look at 40, well, 40 is about here, right? Because we're going up by 30s. So if I say about there, and then I look to where 140 is, see how they're equivalent values? So this is your nice general rule, but then this is your curve that you can look at to check that you've done the right thing. So that is the sine curve.